Hello everyone, welcome to my channel. Okay, and as we know, due to this corona pandemic, we are facing lots of problem to continue our study. Okay, although for class 12 we were at the end of the course, we officially declared the end of the course, but still there was time for revision. Okay, there was very crucial period of revision classes where we could go to the past questions and try to solve them. Okay, since we are lacking that, so to benefit my all students, all of you, okay, I have started this YouTube channel to provide you some revision classes for physical chemistry. Okay, some chapters of physical chemistry. Okay, so without wasting this time, okay, let's talk about this first chapter of physical chemistry, that is known as chemical thermodynamics. Okay, now what is chemical thermodynamics? How do you define it? So the branch of science which deals with the energy changes in physical and chemical processes is known as thermodynamics. So basic thing what you need to remember is thermodynamics deals with the energy changes between system and surrounding. Okay, so there are some basic terms of this thermodynamics. First is the system, a specified part of universe which is under observation or study is called system. Okay, for example, if I am talking about this pen, if I am observing or if I am investigating this marker, then this marker becomes system for me. If I am studying about this whiteboard, the whiteboard becomes system for me. Okay, so whatever you consider under investigation or study, that is said to be the system. So the specified part of universe which is under observation or study is called system. And similarly, what is surrounding? The remaining portion of the universe which is not a part of the system, it's called surrounding. So in simple words, the thing we are observing, that is system, everything else becomes the surrounding. Okay, and in thermodynamics there is an exchange of energy between system and surrounding. Okay, and always the system plus surrounding is equal to universe. Okay, so that is the basic terms regarding the system and surrounding, and there is an imaginary boundary. Okay, for example, if this is a system, okay, if this is a system and everything else will be surrounding, everything else will be surrounding. So system and surrounding, they are separated by an imaginary line called boundary. Okay, and system plus surrounding, that is equal to the universe. Okay, so there are three types of system. Okay, so one is open system, a system that exchanges both matter and energy with the surrounding, that is known as open system. It exchanges both matter and energy with the surrounding. Open system, it exchanges both matter and energy with the surrounding. Okay, and for example, if we keep hot water in an open vessel, then what happens? Then the hot water, okay, the water also, matter also escapes as water vapor, and your energy, heat energy, is also lost in the surrounding. Okay, so and second one is the closed system, system that exchanges energy but not matter with the surrounding. This closed system, it exchanges only energy but not matter with the surrounding. It do not exchange matter, it exchanges energy only. For example, if we keep hot water in a closed vessel, what happens if we keep a hot water in a closed vessel? Heat will be lost, that means energy will be exchanged, but matter, water vapor, cannot be exchanged. Okay, and another example is hot water in a closed vessel. So another is isolated system. Isolated system is the system which can neither exchange mass nor energy with the surrounding. For example, if we keep hot water in a thermos flask, what happens there? Matter, that means water vapor, that will also not be exchanged, and similarly energy will also be conserved. Okay, energy will also be not exchanged, it will still remain hot. So that type of system is said to be an isolated system. Okay, so these are the three types of systems. Okay, now the macroscopic properties of system. So what are the macroscopic properties of the system? First of all, we need to know that thermodynamics deals with the matter in terms of bulk or large number of chemical species behavior. It does not depend upon the behavior of a single molecule or single species. It deals with the behavior of large bulk of chemical species. Okay, so the properties of the system which arises from the bulk behavior of matter are called macroscopic properties. Okay, so the properties of the system which arises from the bulk behavior of matter, okay, are called macroscopic properties. The common examples of macroscopic properties are pressure, volume, temperature, surface tension, viscosity, density, refractive index, etc. The macroscopic properties can be divided into two types. They are intensive properties and extensive properties. Okay, now intensive and extensive properties. Okay, these are the two macroscopic properties of the system. So what are intensive properties? The properties of the system whose value is independent of the amount of substance present in the system. They are called intensive properties. For example, temperature, pressure, surface tension, dielectric constant, water vapor pressure, specific heat capacity, refractive index, etc. Okay, so these parameters or these properties of the system, they are independent upon the amount of substance taken. For example, if you have a vessel containing water, boiled water, okay, so if you take 1 liter of water, its temperature will be same. If you take whole water, its temperature will be same. Okay, similarly its pressure will be same, its specific heat capacity will be same, and so on. Okay, so those are the intensive properties. Now extensive properties, the properties of the system whose value depends upon the amount of substance present in the system, they are known as extensive properties. Okay, for example, mass, it depends upon the amount of substance taken. If you take more, there will be more mass. If you take less, there will be less mass. Similarly, volume, surface area, free energy, enthalpy, entropy, etc. So these are the extensive properties. Okay, these are the two macroscopic properties of the system.